Okay, so today we're talking about one of the most widely used tools in process control, which is the PID feedback control. So to start, can you explain what PID control is in its general terms?
Sure. PID stands for Proportional Integral Derivative Control, and it's a type of feedback controller that automatically adjusts a process to keep the output as close to the desired set point as possible. It measures the error between the set point and the actual process variable, and then uses three terms, P, I, and D, to decide how the controller should respond.
So then, can you break down what each of these three terms do?
Absolutely. The proportional term reacts instantaneously to the size of the error. Bigger the error, the bigger the corrective action. The integral term looks at the error over time, which helps eliminate steady state offset and eliminates gain. The derivative term predicts where the process is heading by looking at how fast the error is changing, which helps reduce overshoot and improve stability. Together, these terms create a controller that can respond quickly, remove long-term error, and dampen oscillation.
Nice. So why is PID so important in the industry and research?
PID control is everywhere because it's simple, reliable, and it works well for a huge range of processes. In industry, it's used in temperature control, flow regulation, pressure systems, reactors, distillation columns, heat exchangers, and pretty much any process where stability and consistency matters. Over 95% of industrial control loops use some form of PID controller. In R&D, PID control is just as important. Whenever you're developing a new reactor, sensor, or prototype system, PID lets you safely test and operate the equipment by keeping key variables like temperature or concentration within safe limits. It also helps researchers evaluate system dynamics, test new materials, and develop more advanced control strategies.
So in short, what's the big takeaway about PID control?
The big takeaway is that PID is the foundation of modern feedback control. It's simple enough to tune by engineers in the field, but powerful enough to keep complex systems stable and safe, whether in a chemical plant, a lab experiment, or a new technology being developed. PID is one of the most essential tools in maintaining control and ensuring reliable operation.
And that's our take on problem 3.